Assalamualaikum. This lecture will continue just a short one, a continuation from the previous topic, fires and explosion. So this is the last part. It's a short one. It involves the calculation for continuation for fire and explosion calculation. So basically, there's an additional method in order to calculate the output of the explosion. We call it as a TNT equivalency method, right? So basically, this is a simple method for equating known energy of combustible fuel. So it's a method for equating known energy of combustible fuel. Imagine, for example, you have a fuel or hydrocarbon. You use it as an explosion. So how can you determine the equivalent mass of TNT based from this fuel, which is not a TNT, but it's a hydrocarbon? So but previously, we determined if the TNT is exploded using the TNT. However, if we use other kind of explosive materials or fuel, so we can calculate the equivalent mass of TNT. So this approach assumes that exploding mass behave like exploding TNT, meaning that the exploding mass using, for example, hydrocarbon behave similar with exploding TNT. So this is the assumption that you use, right? So this MTNT, this is the one that we want to calculate. This is so what is this equivalent mass of TNT, the one that we want to calculate. This is the empirical explosion efficiency. Normally is given the explosion efficiency. This is the mass of hydrocarbon that we use. For example, if we use a methane, so you use the mass of methane. This is the energy of explosion, combustion energy, and this is the energy of explosion for TNT. And the heat of combustion for the flammable gas can be used in place of energy explosion. So normally this one is given, this one is given, this one is given, and this one is given. So from this equation, from mass of hydrocarbon used in explosion, you can convert it into the equivalent mass of TNT. Okay, so this is the equation that you use if the explosion is not using a TNT itself, right? So the explosion efficiency is one of the major problem in the method. So sometimes the efficiency of explosion efficiency could be high or could be lower, right? So this one you just go through it. You want to determine the total quantity of flammable material involved in the explosion, estimate the explosion efficiency, calculate the equivalent mass TNT, and use the scaling law to estimate the peak side on overpressure as we mentioned, as we have done it in the previous chapter. And then from that peak overpressure, we estimate the damage for the common structure of process equipment from table 6.9, similar in the previous slides explained to you. And also, the procedure can be applied in reverse to estimate the quantity of material involved based on the damage estimation. For example, you know what is the damage estimation. So from that damage estimation, you can reverse engineering it so to determine the quantity of material. So you can do a reverse engineering or reverse calculation on that. Okay. So TNO multi-energy method is from Netherlands. Right, just go through it. So I'm not going to, you can just read the slides. I'm going to the example. Right, this is an example. We have a 1000 kilogram of a methane. Okay, we use a methane here, not a TNT. Escape from a storage vessel, mix with air and explodes. Right, so determine the equivalent amount of TNT. So we have a methane here of 1 kilogram. You know a mass of methane. You need to calculate the equivalent mass of TNT. So once you have calculated the amount of TNT, determine the site on peak overpressure at a distance 50 meter. This is R. from the blast and estimate the possible impact to the structure. So B is the same as the previous in the our last lecture. I mentioned to you how to calculate how to impact of the structure, and assume the explosion efficiency is 2%. So we do A first using the equation, right? So A MTNT is 2% is the efficiency. 1 kilogram of the methane. So this is just a conversion, right? Divided by 4680 the data combustion. So you get 214 kilogram of TNT. So 1 kilogram of methane is equivalent to 214 kilogram of TNT. So that is the equivalent mass right now. So B, so we do the normal, the common in the previous chapter. Z, you find the ZE, radius is 50 meter. So you got the M already, M of TNT, okay, 8.4. So from figure 6 from this figure, you get, you know the R, you know the ZE, you can take the PS is 0.25. So you can calculate P naught is PS times PA. So you get, this is PS times PA equals to 25 kilopascal. So what this, how much 25 kilopascal can done damage? So this 25 kilopascal overpressure will demolish steel panel buildings or ruptures oil storage tanks, as mentioned in table 6.9 provided to you in the previous slides. So this is just a continuation from the previous calculation method, just additional in A. So you calculate the equivalent mass of TNT first before you do the calculation for B over here, right? So basically, this is just, you can just read through it. It's another equation, fireball from belief. The maximum diameter of fireball is given by this empirical equation. You can get the maximum diameter of the fireball. For example, D is the maximum diameter of fireball. M is the mass of fuel. So duration of the fireball in the air. So you can, from you have the mass, you can get the maximum diameter of fireball, and this is duration of the fireball in the air, TD. You have the mass, you can calculate the durations from this equation. So just a direct equation translation over here. So this is the probit for death due to thermal radiation. Okay, just go through it fast. We've gone through this before. This is the heat flux received by target to distance the ground from the center of fireball. So the heat flux, the radiation heat flux, QE. P is the number of transmittivity, number in is normally is 1, E the radiation flux. F is the view factor. L is the distance. So these are all the equation for you. For another, you just go through the equation over here. Okay, all right. So the rest would be the vapor cloud explosion. I guess we have gone through this. All right, so that's it for the final part of the fire and explosion, which is the TNT equivalence method. With that, thank you very much.